What if I told you that everything you know about the Atlas object is wrong? NASA released the data, but they didn't tell you the whole story.
3I Atlas isn't just another rock floating in the void. It's an anomaly that defies our standard classification models.
When we look at the orbital trajectory released last month, the numbers don't add up. The eccentricity is off by a significant margin. And
normally, a parabolic trajectory implies a one-time visitor. But look at this curve right here.
It curves inward. That shouldn't be physically possible for a rock of this mass without an external force. Astronomers call this non-gravitational acceleration. Usually this happens when comets outgas near the sun, acting like little thrusters.
But here's the kicker. Atlas didn't have a tail. No coma, no outgassing. It was accelerating, silently.
If this sounds familiar, it should. We saw the exact same behavior with Oumuamua back in 2017. And NASA knows it.
Same velocity, same hyperbolic entry, same unexplained push. It's like lightning striking the same spot twice.
I dug into the archives. Page 47 of the preliminary report. They tried to bury this in a footnote. It mentions anomalous spectral reflectivity in the infrared band. In plain English, it was shiny. Too shiny for an asteroid.
Natural space rocks absorb most light. Atlas was reflecting it like a mirror or polished metal.
High reflectivity. Non-gravitational acceleration. No dust tail. These aren't random coincidences.
Harvard professor Avi Loeb suggested this years ago. A light sail. A piece of
So why did the initial press release call it a comet? Why ignore the data that screamed artificial? Then there's the rotation. Normal asteroids spin on a principal axis. This thing? It was tumbling chaotically. And
imagine a dinner plate flipping end over end in a hurricane. That's the movement profile we're talking about.
The brightness dropped by a factor of 10. 10 times dimmer, then bright again, every 8 hours.
A sphere doesn't do that. A cigar shape doesn't even do that to this extreme. Only one shape fits the data.
It's flat, extremely thin, like a pancake, or a manufactured structure. We trace the trajectory back. It didn't come from any known comet cloud. It came from the direction of Vega. Before it entered our system, it was sitting at the local standard of rest. That's the galactic average velocity.
It wasn't moving towards us. We ran into it. It was like a buoy floating in the ocean, and our solar system was the ship.
What are the odds that the first interstellar object we ever find is parked in a specific galactic holding pattern?
statistically, 0, unless it was placed there. Unless it was waiting. Let's talk about density. At that rotation speed, a loose pile of rubble, which is what comets are, would tear itself apart.
Centrifugal force should have turned Atlas into dust. But it didn't. It stayed solid.
That requires a tensile strength at least 10 times greater than typical asteroid rock. We're talking about iron or alloy. Green Bank Telescope turned its dish toward Atlas for 6 hours. They were listening for a ping, a signal.
Officially, they heard nothing but cosmic background noise. But here's where the timeline gets messy.
The data was collected on the 14th. The public statement didn't drop until the 28th. 2 full weeks.
In the digital age, a 14-day delay for high-priority astronomical data is an eternity. It's unprecedented.
What happened in that gap? Classification reviews? Threat assessment? Or were they sanitizing the data set?
We know protocols exist for post-detection scenarios. They're designed to prevent mass panic.
But while the public was being told it's just a rock, private contractors were already drafting intercept missions. Enter Project Lyra.
The concept is simple but technically nightmare-inducing. We are trying to catch a bullet with another bullet, while both are moving at orbital speeds.
Atlas is exiting the solar system at 26 kilometers per second. Voyager 1 took decades to reach that speed. We need to do it in months.
The plan involves a Jupiter assist followed by a solar Oberth maneuver, diving into the sun to use its gravity well as a slingshot.
It's the most dangerous flight path ever calculated. 1 degree off, and the probe vaporizes. But it's the only way to catch up.
These proposals aren't cheap. They cost billions. You don't spend that kind of money to chase a rock unless you know it's worth catching. Critics argue that a light sail, something less than a millimeter thick, would be shredded by interstellar dust before it ever reached us.
Traveling at 26 kilometers per second, a grain of sand hits with the force of a bullet. It should be Swiss cheese.
Unless the material isn't aluminum or mylar. Unless it's an engineered alloy with self-healing properties. Or maybe we're looking at it wrong. Maybe Atlas isn't a ship. Maybe it's wreckage. A shard of something much bigger.
Space junk, but not ours. Debris from a galactic war or a dead civilization, washing up on our shores.
This space trash theory actually solves the tumbling issue perfectly. Broken things don't fly straight. They spin. They drift. Of course, mainstream astronomy hatted the alien word. They scrambled for a natural explanation. Enter the hydrogen iceberg.
But the theory is elegant. A chunk of solid hydrogen. As it melts, the gas is transparent.
But there's a thermal problem. Hydrogen is incredibly volatile. A chunk that size would have evaporated millions of years ago.
To get here from the nearest molecular cloud, Atlas traveled for hundreds of millions of years. A hydrogen iceberg wouldn't survive the trip.
Then they pivoted to nitrogen. They said, maybe it's a shard from a Pluto-like planet. Frozen nitrogen is solid, and it's invisible when it melts.
But pure nitrogen is rare. To get a chunk the size of Atlas, you'd have to strip the crust off 1,000 Plutos.
The math doesn't work. The abundance of nitrogen in the galaxy isn't high enough to make this statistically probable.
When you eliminate the impossible natural explanations, whatever remains, however uncomfortable, must be the truth. It was artificial.
This is why the Galileo project was founded. To stop guessing and start looking for evidence. Hard evidence.
But here's the twist. We don't need to chase Atlas to find the truth. Because 3 years before Atlas, something else arrived.
January 8, 2014. A fireball exploded over the Pacific Ocean near Papua New Guinea. Sensors picked it up immediately.
It was cataloged as CNEOS 2014-0108. Just another space rock, right? Wrong. The speed was the giveaway.
It was moving too fast to be bound to the sun. And when it hit the atmosphere, it exploded much lower than it should have.
That means it was tough. Tougher than iron. Tougher than any stony meteorite we've ever seen. It was made of something else. It took 3 years of lobbying, but in 2022, the US Space Command finally released the memo. They confirmed it.
99.999% confidence it came from interstellar space. We had an alien visitor sitting at the bottom of our ocean.
Most scientists would just write a paper. The Galileo project team? They rented a ship. They went to Papua New Guinea.
They dragged a magnetic sled across the impact zone, a mile deep, fishing for needles in the biggest haystack on Earth.
And against all odds, they found them. Tiny metallic spherules, the melted remains of the object.
They analyzed over 700 spherules at Harvard, Berkeley, and the Bruker Corporation. Most were normal background dust, but 5 stood out.
They contained extremely high abundances of beryllium, lanthanum, and uranium. We call it the Galileo composition.
This isn't a mix you find in nature. The abundances were hundreds of times higher than the solar system standard.
It looks like differentiation. Yeah. Like the heavy stuff that sinks to the core of a planet. Or the waste product of an industrial process.
Technological dross, the slag left over from a reactor or an engine. That's what Galileo looks like.
2 objects, 5 years, both from interstellar space, both harder than rock, both behaving strangely. This isn't a fluke anymore, it's a pattern. We aren't finding the Starship Enterprise, we aren't finding their ambassadors, we're finding their garbage, their discarded plastic bottles drifting on the cosmic tide.
If we stumbled upon 2 of these in just a decade, statistically, that implies there are quadrillions of them.
Quadrillions. We are swimming in them. A swarm of interstellar debris that we never noticed until we turned the lights on. Unless they aren't trash. Unless they are sensors.
Bracewell probes, designed to activate when they find life.
The idea is simple. You send a probe to a promising system. It parks itself in a stable orbit, it shuts down, and it waits.
Waits for what? Noise. The moment the local wildlife figures out how to build a radio transmitter and starts leaking signals.
We've been broadcasting for about 100 years. That is a blink of an eye in cosmic time. And suddenly, 2 visitors appear?
If they were just rocks, we should see 1 every few centuries. Seeing 2 in 1 decade suggests they were triggered. They woke up.
That acceleration near the sun? Maybe it wasn't outgassing. Maybe it was a course correction, a recharge, or a data transmission.
This brings us to the ultimate nightmare scenario. John von Neumann's theory. Self-replicating spacecraft.
A probe arrives, mines raw materials from an asteroid, and builds copies of itself. 1 becomes 2.
If just 1 civilization did this 1 billion years ago, every square inch of the Milky Way would be saturated with their probes by now.
Like dandelion seeds blowing in the wind, most land on barren ground. But some find a garden like Earth.
So if they're everywhere, why haven't we seen them landing on the White House lawn? Because that's not what they are designed for.
And they aren't diplomats. They don't care about us. They are automated loggers, mapping star systems, recording biology, sending packets home.
In fact, they might be dead. The civilization that built them could have died out 1 billion years ago. These are just ghosts in the machine.
We aren't doing first contact. We're doing space archaeology. We are digging up the artifacts of the Milky Way's history.
But we are getting better at spotting them. Next year, the Vera Rubin Observatory turns on. It will change everything.
It won't find 1 object every decade. It's predicted to find 1 interstellar object every single month. The floodgates are opening. We are moving from a data drought to a data flood. And when that happens, the anomaly explanation stops working.
The biggest barrier right now isn't technology. It's the giggle factor. It's the stigma that shuts down careers.
We have a history of ridiculing what we don't understand. We'd rather be alone than admit we might be the ants in the ant farm.
Carl Sagan famously said, "Extraordinary claims require extraordinary evidence." But Avi Loeb has a counter to that. Extraordinary evidence requires extraordinary funding, and extraordinary conservatism keeps that funding locked away. Ignorance isn't safety. If there is a probe checking our atmospheric composition, don't you think we should know who sent it? We are assuming they think like us, but the technological gap between us and a starfaring civilization is like the gap between a carpenter ant and a smartphone.
To a caveman, an iPhone isn't technology. It's a shiny rock, maybe a magic rock. But he doesn't see the circuit board inside.
That's what Atlas was. We saw the shiny rock. We missed the circuit board. Because we didn't want to look. But the time for looking away is over. The sensors are upgrading. The data is coming. And we need to be ready for the answer. Science is conservative by design. It demands proof. But sometimes extreme conservatism turns into blindness. It stops us from asking the question. There is a reason it's called the Galileo Project. Galileo was put under house arrest. His crime? Looking through a telescope.
He dared to suggest that the Earth wasn't the center of the universe. The authorities didn't want to look. They refused to look.
Today, the center of the universe is our ego. We assume we are the only intelligence, that we are special. That arrogance is dangerous. It blinds us to the data. It turns anomalies into errors. It turns visitors into rocks. But we are finally building the right eyes. We are training AI algorithms to look for non-gravitational acceleration in real time.
No more 2-week delays. No more human error. The next time an object deviates from its path, we will know instantly.
And this time, we won't just watch it fly by. We have the interceptors on the drawing board. We have the math. The question is no longer, are we alone? The question is, are we ready to meet the neighbors? Atlas 3I might be gone. It's heading back into the void. But it left us with something more valuable than metal. It gave us a wake-up call. It broke the stigma. It forced the scientific community to admit that our models of the universe were incomplete. And we are leaving the era of passive observation and entering the era of extraterrestrial archaeology.
we are finally ready to dig. Because the next visitor is already on its way. It might be passing Jupiter right now. And this time, we need to catch it.
I want to know what you think. Was Atlas a hydrogen iceberg or a broken piece of alien tech? Let me know in the comments below.
If you enjoyed this deep dive, hit that subscribe button. We have more files to declassify soon. Until next time, keep your eyes on the skies. Thanks for watching.